doing the monitoring, and especially in automatic case, this information is received by the people in charge of optical fiber maintenance almost in the same time. And also, if there is no this kind of procedure, sometimes the people of the equipment ask the people involved with the optical fiber maintenance to do some tests, and the tests are in parallel just after to discover if it's a fiber problem or if it's an equipment problem. When you use this, it's easy to check immediately if there is a problem or not with the fiber, and do or not some action. Okay. This kind of test, the loss testing, and also the power monitoring, through the continuous monitoring of power level received at the end the optical fiber just before receiving the equipment. These testing are able to collect and store power level data and provide immediate detection of fiber faults through the activation of the OTDR function. Then the idea is that if the system has some measurement of loss test of the power monitoring, it's possible to identify and put the OTDR in operation to measure the fiber affected when is necessary. Then one could work together with the other system. All these systems are designed to minimize the service outage as well the economic loss through the immediate location of failure and alarm generation, and at different degrees are intended to predict failure due to degradation of the fiber performance. This is important because the people involved with this network could establish what are the margin of attenuation in this link and to follow what is happening, because it's usual the attenuation change during lifetime of the cable, and it's caused by a lot of different situations. It's difficult to know what is happening there. It's usual to have some punctual elements, such as people will do some changes in fiber position in the station and not trying to take. Sometimes it's happens to change the position of other fibers, and these other fibers could have an increase of attenuation. There is some mistakes that could be done in the field related to connectors, and sometimes this degradation of the attenuation of the link could be related to some specific point, not so clean connector or things like that. Sometimes a wrong connector used that increase the loss at that point, or also could have some relation with some degradation of the fiber. It's easy to know this when we are using the OTDR curve. Then it's very important to have this perception if this increase of the fiber occurs along the fiber or if it's specific, it occurs in a specific points. Then all of this use for kind of tests could be used in a good way to solve problem when it occurs or to know problem before it occurs. And that's the idea, to use these tests to do the activity and reach the result of that function established in the strategy of this system of maintenance, preventive or post-fault. This is a distribution of the use of these different techniques in the same table we discussed before. Then it's more related to what system could be used, what equipment, or what technique. Let's take care with this information. It's a lot of information, but it's not so it's not so easy to see everything, but it's not so difficult to understand what could be done to help the maintenance of our network. Let's take a look what could be done. When you consider the preventive maintenance, the surveillance could occur when we detect, when there is a detection of the fiber loss increase, and this is generally done using OTDR or loss testing. The detection of signal power loss increase is done using power monitoring. And the detection of water penetration could be done also for OTDR and loss testing. In this case, what the kind of water penetration we consider here is the kind of water that gives some effect in the attenuation of the fiber, of course, because it's some case when the water penetrates in some parts of the network, but it doesn't affect the fiber. Could be outside the cable, could be here we are considering the water penetration inside the place the fiber is physically and affect the attenuation of the fiber. There are different kinds of systems. Returning to that question of what could be done, there are different kinds of systems that are intended just to identify the water presence. Then it's one step before. You can just put some absorbing materials. It's one of the systems, one of the principles that could be used. You can put some absorbing materials that when there is water in this position, the materials becomes bigger and press some fiber specially used for disease detection and increase the attenuation of this fiber. And the same OTDR that is doing the surveillance of the fiber used as part of the cable could also be used to detect this increase of attenuation related to this specific device, and the people could go to that position in the network and do the action to correct. Other activity of preventive maintenance is testing. Then the idea is to use the OTDR to measurement that allow identify the location of the fault, the fiber fault. And also, we can do measurement of fiber strand distribution using some special kind of the OTDR, and do measurement of water location using the same, usually used OTDR. The third activity of preventive maintenance is the control and the fiber identification, the identification physically of the fiber that's under this situation could be done for the device called ID light detection. Is a device that allows people to see or not the fiber and the light in one specific fiber, and also can identify the fiber transferred, considering the switching. This switching includes mechanical and manual switching in this concept, and the ID light, it means identification lights. It is a kind of device that uses modulated light that allow the people to identify if that specific fiber has the light or no. Considering the category of activities done by after the installation and before service or post-fault maintenance, the surveillance, we can see the interface with PAT operation system Then there is sometimes it's done online or through external medium, and also the interface with the customer. Same way, we can use some kind of system to register, to put information that could be online, or put this information in some kind of report and send to the people that are involved to keep the system with the right information. The idea is not to lose the control of the information we have relative to the network. The testing could be done for the confirmation of fiber condition. It could be used both OTDR and loss testing. Testing could be done also to fault distinction between transmission equipment and fiber network. It again could be done using OTDR or loss testing. It could be done for the measurement of fiber fault location. Then it's just to use OTDR. It's necessary to use OTDR to identify the place the fiber has this kind of interruption, physical interruption. The third one is control. It's necessary to check sometimes the fiber identification. Then it's use the ID light detection. To control is necessary to identify the fiber transfer. Most of the time they are registered of these, what we call switching information. And also it's necessary to put the right information in systems here considered by their interface. And there is interface with outside plant database and interface with mapping system. The idea of this is to keep track what's happening. The idea of this is to have some specific information about the fiber, the value, the location. And the idea of control is after put the system. Okay, again, is to put this information in the means that the company has relative to this information, the fiber and the customers and the map of all the information we have relative to that specific optical network. Some question about this? The main intention of this first table, was establishing a strategy. The main intention of this second table is to put information about the test or the method of test or the equipment we can use. And another important point is to consider what kind of wavelength we can use to do this. Then just to have in mind, first, establishing a strategy. Second, identify what kind of methods we can use to do some activity and to reach the result of that function. Another point important now is what kind of recommendation we can have about the wavelength that could be used in any of these activities, just to do in the right way and solving the problem eventually we have in the network without causing any other abnormality. That's the point. Then the idea expressed here, they are more detailed in some recommendation, like L41, and there's a lot of work done in some recommendation, name it here, and the supplement of this recommendation, to establish this kind of this decision. Then everyone that is interested in know in detail of this slide in the next one, we'll go in more detail relative to this wavelength, could see more detailed information in this document. Let's take a look what's more important in this point of the presentation. There is a lot of wavelengths that are being used for the transmission of the signal, transmission of the service to this optical signal. We need to care about some situation. We use wavelength, and sometimes in the same fiber they are transmitting this useful information for the customer. We need to transmit also useful information for the operation of the optical plant. This way, for the power monitoring system, it's important to choose this correct wavelength to be monitored, especially when maintenance functions have to be performed without interfering with data transmission signals. In both cases, preventive maintenance and after installation, before service, or post-fault maintenance, when we do the first one, surveillance, when we detect the fiber loss increase, the idea is to use a specific wavelength that we call maintenance wavelength. Then the system, the recommendation is not to detect the fiber loss increase using any wavelength, but the specific one assigned to maintenance. The detection of the signal power loss increase could be done in, or must be done, in the signal wavelength. In the detection of water penetration could be done in any wavelength on fiber not carrying signals. Then more and more in DWM system, we have a lot of signals. Some wavelengths in that signals could be carrying information, another no. The idea is to find in the system some wavelength related to fiber that are not carrying signals and do the testing the testing. The test we can use for measurement of fiber fault location, fiber strength, or measurement of water location. We can use always any wavelength on fiber not carrying signal. And for control, the fiber identification, the recommendation is to use maintenance wavelength, and fiber transfer doesn't use measurement, doesn't use information of this kind, and it's not necessary to have some wavelength allocated to this function. After installation, before service or post-fault maintenance, for surveillance, we don't need any wavelength allocated. For testing, we need confirmation of fiber condition. It's possible to use any wavelength. Fault distinction between transmission equipment and fiber network is possible to use any wavelength. And measurement of fiber location is possible to use any wavelength. The idea is to choose and to proceed the best way to solve the specific problem. For the control, the fiber identification, we don't use any wavelength. For the other operation, it's not necessary to allocate wavelength. Then the more important point is that testing or surveillance, in some case, we need to use the maintenance wavelength. In the other ways, we need to use any wavelength on fiber not carrying signal. Then we can look at the different kind of wavelength used in this kind of system and discuss what will be this intended maintenance band. Okay, here we have the allocation of wavelength in three system that can cover all the situation. The first one is the ZIG and recommendation L41 and the supplement 39. of the G series of recommendation. The second one relates to this more, the first one is more related to all systems. The second one is specifically related to PON, and the third one is specifically related to CWDM. On the first, we have the more general one, we have several bands of transmission, and it was chosen as maintenance band this end of the this set of wavelength. Then normally we used to do this one, but there is some U band that could be used. The same U band is used in Japan, and the same U band is used in CWDM. Then, at the beginning, all of this system could be analyzed using OTDR specific design for U band, and the system could receive a lot of signal information, and the test of maintenance could be done in this U band. Some doubts about these two slides. The first one is the wavelength allocation. The second, that's complement just the band allocation, wavelength distribution in bands used in communication. Most of the time we just choose one system and work as here. If you are in conventional system in C-band most of the time, and GPON depends, and WDM, we have a lot of possibilities. In all the strategies based on use some wavelength for maintenance that that not interfere with the signal that are being transmitted. Another kind of view of this situation is that we always need to have in mind that there are several recommendation maintenance wavelength bands depending on the communication light wavelength used in a given transmission system. We can use different parts of that U band, and when the communication wavelength band extends to the L band, the wavelength used in the ultra long wavelength band is used for maintenance test. Then just to keep this in mind. And here we have a set of cases that we can consider in this one. This to see more in detail this situation. In case one, we have one window active, and second window, the first one is active, the second window is vacant or maintenance. We can also have maintenance in the U band. In the second case, we have the first window vacant or active, and the second window, the first one is vacant or active, the first one is active, and we can have again the maintenance in U band. When both windows are active, we still have the possibility of have the maintenance wavelength in U band, and sometimes there is some active systems in U band. Then the idea is to use a higher wavelength to have the maintenance. Then some systems start to using this portion of the window of wavelength initially dedicated to maintenance band, and when we have active here, it's better to use higher wavelength. And these two values, they are relating to the facility we can find in terms of lasers and detection system. And the idea is just that. If the system is working around the first window, it's in O band, or around the C band, we can use the U band for maintenance. If your system starts to use more wavelength near the U band, what they call L band, then we need to go just a little far from the wavelength used for transmission of the system. That's the idea of this table. And again, there's more information on L41, but I think for the purpose we intend to cover here, this could be enough. Any question about this?
Most of time, the wavelength used, it's 1310 and 1550. Yeah, for transmission. On which basis an operator should choose 1310 or 1550? Thanks.
You are dealing more with the wavelength choose to operate the system. Yes. I will ask you to keep this question in mind and to address the people that will discuss the system, because it's better to have it in mind. What we need to have here in mind is that the position of this information is in the end of the handbook. It's chapter 10. But some colleagues that will be the tutors of next week, they taught this way. They will be here discussing more questions related to the system. But some part of this information is important to have in mind because it deals with the fiber and the operation we did in the fiber. Then, of course, there are some questions related to the availability of equipment. There are questions that could be addressed in this situation to choose the evolution of the system. Let's take just an example. I'm sure they will show you the big difference in having a CWDM here or CWDM here. Here we use what we call, I will just address some part of the information you asked related to fiber and cable, okay? And some part of the answer of your question, I prefer to discuss with people of the system. Considering the information related to the different kind of fibers, we trying to design or trying to use what's designed, considering the laser photodetector, detector, the attenuation of the fiber, and of course, in this way, the extension we can reach. Normally, what is used is that we use first for long distance the kind of wavelength, and it's called first WDM, DWDM, when we split all the wavelength around 1550 nanometers. And at the beginning, people start to develop some cheapest component that we call coarse DWDM. Here we have the dense DWDM. Here we have the coarse DWDM. The main difference between the two systems is how wide is the curve of wavelength in each of these called transmission wavelength. Then at the beginning, we have more spread wavelength in CWDM and more tight signal in DWDM. As we have more wide here, it's possible, or it was intended to be possible, that the components related to the emission of the light and to reception of the light, they could be cheaper here in CWDM than here in the WDM. That was the first idea. Then the idea was to use the 1550 for long distance because of the lower attenuation, and also because in long distance, generally we have more signals, more clients, then could put more money. And when we have less signal, less money involved, we can use cheapest components. That was the idea. But things don't happen this way, and in some cases, the components of DWDM around have the same price as CWDM. And what is happening now is that the people that use this kind of CWDM system could use the same CWDM system at the city to do the same with DWDM. Then the idea is to use more and more wavelength around 1550, including this system used in cities. That's why I'm following. I'm just looking more for the fiber and the cable. And at the beginning, there were some consideration, such as the fiber sensibility is different in one another window, then could be useful to have fiber in this window. Now they starting putting the market fiber with less sensibility, and you can use at the beginning this fiber for. I think you have some discussion at the beginning of the week related to this. The point is that when some fiber, some kind of system is first developed, someone has in mind some kind of application. But the people use to spread this kind of application. Então, I'm seeing a lot of DWDM proposed for cities. I have seen some CWDM mixing, using part of the wavelength of the same principle, but inside 1550 band. Then the price of the system, it's important point to be considered. The possibility of evolution is another. Then it's normally today to see just stopping talking about this and looking outside, looking what's happening after standardization. Standardization is just one point. It's normal nowadays. Some company ask for 2.5 gigabit and receive proposal for the same price for 10 gigabit, and also the company ask for a limited number of channel and receive proposal of a system that's ready to operate for 10 times the capacity asked initially by the company. Then the tendency is to have more and more 1550, and to have the system, long distances, prepared to receive 2, 5, 10 times more wavelength that the company have in mind, the operator have in mind at the first moment. I think most of the recommendation we have represent a consolidated situation, and what always happen is that the word evolution change the points pointed in the recommendation, and also the recommendation done has it's a proposal of a way to be followed. We always need to have that in mind. Okay, as we will move to the in-service line testing, I'd like to ask you if you have more or any question about first the strategy, and second the allocation of wavelength to this maintenance. If not, we can move to this part of the recommendation that established the inline service, the the in-service fiber line testing. These in-service fiber are important in terms of monitoring, and these techniques are highly reliable. They are more applied to higher reliable network, and that especially that network that transport DWDM signals, and with a wide spectral bandwidth. Because the idea is that inline service could help to understand the situation, solve the problem, involve a lot of signal transmitted. The fundamentals of this technique is that it should be carried out without degrading the optical communication signal, and it must be capable of evaluating optical fiber characteristics even if there is interference with the communication signal. The idea is to have this in mind, and the wavelength bandwidth and the output power of the test light source should be designed taking into consideration the cutoff bandwidth and cutoff value of the optical filter, respectively. Moreover, in order of accurate measurement of these characteristics, the measurement equipment such as OTDR or optical power meters should have a tolerance to communication light power. These points are important to have the inline testing system. Then the idea is when you have, like here, optical line terminal and an optical network terminal, there is a signal being transmitted here, and this measurement equipment use an optical coupler to get part of the potence, the power we have in this line, and analyze what happened with this power. Then we are doing some testing, most of the time, all the time, and using part of the power that is used by the two equipments. This data, all the data collected on this, could be just going back here, because another way of some of the questions will arise later, better to deal with this now. If we have a lot of fibers in the same position, we can put an optical switch here and test different of these fibers doing using the same equipment. Then one device that's generally used to have an opto switch here, and this measurement equipment analyze one, another of the fiber of that cable, or could be also applied in a station when selected fiber of different cable that are considered the critical ones could be analyzed in the same manner. The idea is the same. We can have one or more fibers going to different locations, and if we have an optical switch here, the people in charge of the operation of the network could select one or more fiber of the same cable, or one or more fiber of the equipment that are in the central, and do this kind of analysis in the fiber they want to follow more carefully. That's the idea. Yes, sir? Here, you can put the optical switch here. Okay? Imagine we have not only one, but you have 5 of these. Okay? This is one fiber. Okay? The optical switch is just a a switch that could receive 2 to 10 or more fibers in and out, and could select one of these fiber, okay? Then, in this case, instead of having this, we can put optical switch in some position here, and we can, having 5 of these, we can get the signal of this system, the other system, the other system, the other system. And, yeah. Because it's, in this case, we are trying to, this is the device that gets part of the power, okay? This is not the optical switch. This is the optical coupler that get part of the power just to be analyzed, okay? If we intend to do the same analysis, not only one, but in 2 or more fiber, okay, we can have the same situation, one fiber, one optical coupler, and a fiber goes to the measurement equipment. And just before the measure equipment, we can have some optical switch to select each fiber we want to analyze at that moment. Do you understand? The setup could be done? No? Imagine you have in this station, this facility. You have some fiber, you have an optical coupler where you can get part of the power, and you have the technique to analyze that power and to follow what is happening in that fiber. Could have in the same station or central office more than one fiber that could be, it needs to be understood or followed. One way of doing this is to have a lot of measurement equipment and put one equipment in each fiber, okay? Another way of doing this is to having all these parts of system and share the use of measurement equipment. In this case, different fibers, different couplers, optical couplers, and different fibers installed, imagine here in 4 of this same situation, can go to some part here, and as we install here an optical switch, we can switch the fiber that the equipment is measuring and measure this system, the other system, the other system successively. That's the idea, okay? It's a way the optical switch. What is in optical switch in this mini is a simple device when you have different fibers going in, different fibers going out, and this device could choose what in and out fiber to connect. In this case, to connect to be analyzed. It's a simple device that can be used to select the fiber we are using. That's the idea. I don't know if there's another name for this. It's not a switching related to the operation of the system. It's just a single device. Then you can switch one fiber to the other. You have 10 fiber going in, 10 fiber going out, and you can select one of these to do the measurement. That's the idea. Okay. I always lost my time. I think it's time to have some break now. Yes, we can resume here. We start the presentation. Looking for some recommendation related to general support system architecture. It's useful to have some system that at least support the operation based on operation terminal and an optical testing module. This is the minimum system. It consists only in these two items. To this type of system, we have some illustration in figure 10.3. It's convenient for the initial operator. Then you have just one of this optical testing module. You have an operation terminal. A server can improve the performance by keeping all the information about the outside plan, the test results, and interface with other systems. This server could also control the optical testing module. There are several choices of data communication network that can be used, and people use the more convenient one. Always the traffic analysis is important for look at the economical aspect of the system. Considering the definition of this architecture, there are some several queues of interface between the operating system, which it runs and operates in operation terminal or a server, and the optical testing module. Sometimes a proprietary interface is convenient for a closed system, and a standard interface are useful for open system, and other times some people used to have a hybrid type system. And we consider the measurement we have mentioned before. It's always the idea is to have this module that is doing the test and to have a data communication network that could link this place where one or more tests are done, and to put all this data in a database to use during tests to register what was measured, and to having this system all the time being actualized to have a high confidence system. One of the main features of this support system is necessary to consider in the way of obtaining the kind of maintenance we have mentioned before. Then one of the features is to be non-intrusive. It's a feature of non-intrusiveness. Only traffic service and due to design of complete passive optical probe. A non-intrusiveness is a key characteristic of the monitoring system, especially when cable owners do not permit to adopt the OTDR-based monitoring system. It's very important to consider this in define this system. The second one is sensitivity. It's necessary that the system have the ability to detect very fast degradation effects, and especially when these degradation effects have a negative influence on optical fiber performance in long period. Then it's better to have in mind the aspects we mentioned before, that mechanical vibrations due to road and traffic and railway traffic could result in increase of attenuation of the fiber, and this system needs to be sensitive enough to detect this. Another important point is to have a real-time alarm reporting. As is defined an optical power and attenuation threshold crossing, events that cross that limit, that value, are immediately detected and reported to the system through a interface in order to fully exploit the capability related to preventive maintenance. Another important feature is to have an automated OTDR measurement activation. In this case, when the threshold crossing event occur, such as a variation of attenuation, this event is reported in order to have a minimum location time when a sudden fault or abnormality is faced. Then the system must be prepared to have the sensibility to measure and to automatically detect when the OTDR must be activated. The final specific features considered this set is the permanent storage of monitoring results. Then the system must have the fiber reference trace in order to enable analysis of what is happening with the fiber. Considering this non-intrusiveness, the sensitivity of the effects, the real-time alarm, the automated activation of the OTDR, and also the storage of the important data, this system will be good to help the people involved in the maintenance of this fiber. There's a lot of systems that around the world that deals with these features. Some has more integration with other systems of the company, what is a lot desired. If there is no such kind of integration, the teams must be aligned, especially the teams related to the operation of the optical plant, and also the team that's responsible for the operation of transmission system, in way to use these features to help when something wrong occurs. One specific point is when we have some system of optical cable carrying high total optical power. It's becoming more and more frequent as the DWDM system start to be spread used. And there are several components that can be used in this case. And this is a table that refers to the function of this necessary to operate this more critical situation. And we can see that there are functions related to the maintenance, and we need to take special care with this high power, total optical power optical transmission. The first function that's considered in this set of function is the connection. The system requirement for this high power light input is that no fiber fuse or intense temperature increase. That is, it's extreme case when the power transmitted could fuse the fiber that are being used. And by fuse here, we mean the physical fuse. The fiber change the physical state and destroy the several layers that were put in the core of the fiber just to establish the transmission. The fiber is kind of melted in this. The requirement for the operation of this system, the connection to other fiber, is that it's not possible to have this fiber fuse, or intense temperature increase. And the way of doing this is, in this extreme system, is to use fusion splice that are splice specially designed to fuse before the main fiber. And in this case, it's not necessary to have optical connector or polishing and cleaning of connector interface. This second important point is that for termination, the system requirements is the no tight bending of optical fiber. Then the method to deal with this is the minimum bending radius higher than 30 millimeters for testing optical fiber cords in optical distribution frames, but fibers with improved bending capability will allow more severe conditions. Then start the use of fiber that can support a lower bending radius. The other function is testing access for optical fiber line, the same requirement as connection, no fiber fuse or intense temperature increase. And the methods used are the fusion splice and also an optical branching with a component with high tolerance to high power light exposure. And the last function is optical switch with butt joint splice connection mechanism. That is a fiber selector. The system requirement is no intense temperature increase or optical loss increase. And the method used for this is the attenuation of high power light or gap between fibers at a splice with the distance higher than 10 micrometers between the two ends of two fibers. With this topic, we finalize the aspects related to maintenance of optical fiber, and we start some talk about optical fiber and cable restoration. The idea is the very large transmission capacity contained in a single sheet of optical fiber cable necessitates to develop it and to implement it, a plan for rapid restoration in case of optical cable failure. The plan should be detailed in terms of action since the alarm is received by the people in charge of this restoration to the completion of the restoration. Then the primary objective should be establish the service as quick as possible, employing some strategy. Then this recommendation deals with the activity someone needs to do to reestablish the optical transmission in case of failure in optical cables. The first strategy is reroute as much as traffic as possible. The second is to locate the cable damage. The third is temporarily reconnect the damaged cable if it's necessary, and so restore the service. After the transmission of an alarm, the fault must be located before restoration can begin. One of the methods used before, mentioned before, the OTDR, is very useful in this case, and this could be considered as this strategy as a fault locating instrument. The main is OTDR. When we have some faults in optical cable, if it contains metallic pairs, there are another kind of test that could be done And if there is a present, if there is optical power or not, could be also checked by appropriate test set. But the main instrument to be used in this is the OTDR, in using the backscattering measurement to identify not only more detailed information about the fault, but especially the position. There is some recommendation regarding to the choice of an appropriate emergent restoration method, and also regarding to the permanent repair. And the follow of one or other depends on the extension of the damage, and particularly on the distribution of fiber breaks. To do the best action, it's necessary to understand the mechanics of cable behavior with regards to mechanical tension applied to the cable, and especially in a damaged situation. And if we understand more about this mechanism of cable behavior, we can choose the best way to act in each case. Generally, the cable damage mechanisms fall in two broad categories. The first one is what we call low tension, and the second one is what we call high tension. The damage mechanism with low or zero tension include fires, when the fiber will be breaked but without tension, include lightning strikes, and include a lot of types of vandalism. Then if someone go there and cut the fiber will be breaked, but the fiber don't suffer some action of high tension. In other cases, the damage pods